In this experiment, we will consider percent yield and percent composition calculations, and we will do so in light of the chemical reaction of magnesium reacting with oxygen in that oxidation reaction. But first, let's run the experiment. To run the experiment, it'll require quite a bit of equipment, but in essence, we're going to need a heat source, in this case, a Terrell burner, and we're going to put some magnesium in a crucible and heat it to a very high temperature, thus facilitating the reaction of magnesium metal with the oxygen in the air to produce magnesium oxide. See equation 1 in the lab manual. The crucible has been pre-weighed. Now to determine the amount of our reactant, magnesium metal, that we're going to use. And just in case we need it, let's go ahead and record the weight of the crucible plus the magnesium metal. We want to control the rate of our reaction so that the material, the magnesium, doesn't burn too quickly. We don't want it to actually catch fire, we want it to react relatively slowly. And we'll control the rate of the reaction using the crucible cover. If we cover the material, then it will be starved for oxygen and the reaction will slow down or temporarily cease. Likewise, if we remove the cover, it adds a lot of oxygen and the reaction can pick up speed. Hence, by merely adding and removing the crucible cover, we can control the rate of the reaction. The starting magnesium metal was a very dark gray. The product, magnesium monoxide, is a very light gray to whitish like solid material. That looks pretty good. Let's set it aside, let it cool to room temperature, and then proceed to part 2. To the cooled material, we'll add some water, mix it up really well to make a slurry, and then run the reaction a second time. The reason for running the reaction in the presence of water is provided in the lab manual text. With it well mixed, let's begin the second reaction. Now, because water boils at a much lower temperature than the temperatures at which we're using, we want to begin the process by gently boiling the water off. We can see from the pH paper that there's more than steam coming off of the reaction. After the water's gone, we can heat the material quite rapidly and quite fiercely, until once again we have our solid product formed. All that remains now, before we do our calculations, is to determine the total amount of product that was formed. An easy calculation. We have but to subtract the weight of the crucible from the total weight of the crucible plus product. Now let's step through a few of the sample calculations. Note, these calculations shown require you to use your measured values. For example, in that equation that you see in step 1, the 4.123 grams of magnesium is a sample mass. You need to use the actual mass of magnesium that you used in that calculation. Note that the step 1 sample calculation employs about 4.1 grams of magnesium, whereas you actually used less than ½ gram. So it's expected that your actual calculations will differ quite a bit from the sample calculations. Moving to the next set of calculations, if you look at step 1 here, which is now the theoretical percent composition, those gram values are actually taken from the periodic chart, and those represents gram per mole. Because this is a theoretical calculation, everyone should have the same value here. This is the only calculation that is theoretical. All others require use of your experimental data. Regarding the calculation of the percent difference, we required use of the theoretical and the experimental. The theoretical is the value which we calculated using the periodic chart, or the 60.31. The 77.9 value in this case is what was recorded from that experiment's experimental data. So in this particular example, the theoretical and the experimental data varied by about 25%. And so with that, you have your experimental data and you have sample calculations as to how to process that data. All that remains now is to put the two together, make your calculations, report it in the report form, as well as the post-lab questions. Thanks a lot, and I'll see you in the next experiment.